In this tutorial, we're going to talk about solutions to ordinary differential equations. And in this question, we have to show that the equation y equals x squared plus 6 is a solution to the ordinary differential equation d squared y on dx squared plus dy on dx minus 2y. So we know that d squared y on dx squared is the second derivative of y, and dy on dx is the first derivative of y. In that case, first of all, let's write our equation as y equals x squared plus 6. And let's say that this is our first equation, so equation 1. Now, we know that d squared y on dx squared is the same as the second derivative of y. So we can write this one as y prime prime. Then our dy on dx is the first derivative of y. So that one can be written as y prime, then minus 2y. So in this question, we need to determine our y prime prime and our y prime. And in this case, our y has been given us, this y has been given us x squared plus 6. So we need to find y prime and that of y prime prime. And y prime is the first derivative of y, meaning when we differentiate y for the first time, that is for y prime. So therefore, let's find our y prime. So our y prime equals, now we differentiate this, we are going to get 2x. Then we differentiate our x, we are going to have 1. So this is the result for differentiating the equation for the first time. Then we need to find our y prime prime. So we have our y prime as this. Then when we differentiate again our y prime, we're going to have our y prime prime. So we're going to differentiate this one. So when we differentiate 2x, we are going to get 2. When we differentiate 1, we're going to get a 0. So our y prime prime has been given as 2. Then the next thing to do is to name our equations as equation 2 and this one too as equation 3. So now that we have our equation 1, equation 2 and equation 3, we are going to substitute them into this to show whether we are going to have our final result as this one. Wow. Now our y equals x squared plus 6. So and our y prime prime equals 2. And our y prime is 2x plus 1. So from here, y prime prime is 2, and then our y prime is 2x plus 1, and then our y is x squared plus 6. So 2 plus 2x plus 1 minus 2 times 2x squared is minus 2x squared, minus 2 times x is minus 2x. So we can see that we have 2 plus 1, 2 and 1 here. We're going to have 3 plus 2x minus this one 2x minus 2x squared. So we have 2 terms here which are like, and one is positive and one is negative. So this one is cancelled. And then we are going to have 3 minus 2x squared. So clearly you can see that our final result shows that the differential equation here, when we substitute them, we are going to have 3 minus 2x squared as our final answer. So hence y equals x squared plus x is a solution to the ordinary differential equation. In our second example here, we want to determine whether y of x equals x exponent 3 on 2 is a solution to the ordinary differential equation 4x squared y prime prime plus 12x y prime plus 3y equals 0. So when we find our y prime and y prime prime out of this equation, and we substitute them into this differential equation, the result should give us 0. So once the result is equal to 0, then it means that y of x equals x exponent, sorry, this is negative 3 on 2 is a solution to the ordinary differential equation, right? So we have our equation y of x as x exponent negative 3 on 2. So let's call this one as equation 1. So out of this equation, we need to generate our y prime, and then after our y prime, we have to determine our y prime prime too. So as usual, the y prime refers to the first derivative of y. So in this case, we are going to differentiate our y for the first time. So let's differentiate y. So when we differentiate y, that's our y prime. We multiply here by the exponent negative 3 on 2. Then we add 1 to the exponent as usual. So we're going to have 3 on 2 x exponent negative 3 on 2 plus 1. So this gives negative 3 on 2 x exponent negative 5 on 2. So this, let's call this one as equation 2. So our y prime is equal to x is equal to negative 3 on 2 x exponent negative 5 on 2. Now let's determine our y prime prime from here. Now y prime prime equals, now we differentiate our y prime again, so we're going to have negative 3 on 2 times negative 5 on 2 x exponent negative 5 on 2 plus 1. So this gives us negative 15 on 4 x exponent negative 7 on 2. So this is our y prime prime. Let's call this one as equation 3. So the next thing to do here is to substitute our our equation 1, equation 2, and that of equation 3 into our ordinary differential equation here. So we have 4, so 4 followed by x squared, and our y prime prime is negative 15 on 4, so negative 15 on 4 x exponent negative 7 on 2 plus, so here is plus 12xy prime plus 12x, and our y prime has been given as negative 3 on 2 x exponent negative 5 on 2 plus our y equals x exponent negative 3 on 2. So now let's further simplify this. So 4 will cancel 4 here, so we're going to have negative 15 x exponent 2 plus negative 7 on 2 using the loss of indices, and here 2 is going to divide 12 and we're going to have 6. So 6 times negative 3 gives us negative 18 x exponent 1, so plus, using the loss of indices, negative 5 on 2 plus 3 exponent negative 3 on 2. So the next thing to do here is to have, okay, sorry, negative 5 times negative 3 will give us positive, sorry, so this one, the negative is not there. Okay, so now our 2 plus negative 7 on 2 is going to gives us negative, sorry, 15x exponent negative 3 on 2 minus 18 x exponent negative 3 on 2 plus 3 exponent negative 3 on 2. So 15x exponent negative 3 on 2 and 3x exponent negative 3 on 2 gives us x 18 x exponent negative 3 on 2 minus 18 x exponent negative 3 on 2. So when you subtract this this one from this one, or this one from this, you're going to have 0. So since the result is equal to 0, then it means that our y equals x exponent negative 3 on 2 is a solution to the ordinary differential equation given. Thank you, and don't forget to subscribe to our channel.